Alright, so welcome back. In this video, we're going to be solving the remaining part of the same paper, October-November 2021, paper 1, variant 2 of the AdMath. The AdMath exam, yes. Okay, so here's question number 7. This is a question from vectors, so yeah, let's get straight to it. It says the diagram shows triangle OAC, where OA is equals to A, and OB is equals to B, and OC is equals to C. The point B lies on the line AC such that AB and BC are in the ratio m is to n, where m and n are constants. Okay, so I'll just write that down, m is to n. Okay, write down AB in terms of A and B. So that means we need to see how we can get from A to B. Okay, so that should be fairly simple. So we'll go from A to O, which is going to be minus A because we're going against the arrow, and then from O to B, which is going to be plus B. So there you go. Then it says write down BC in terms of B and C. So again, should be fairly simple, from B to O. So that's minus B for the same reason, because we're going against the arrow. And then from O to C, which is going to be plus C. Okay, so that's taken care of. There you go. Then it says, hence show that n times A plus m times C is equals to m plus n times B. Okay, so what can be done over here? Now, earlier the question told us that AB and BC are in the ratio m is to n. Now, thankfully, we know what AB is in terms of A and B, and we know what BC is in terms of B and C. So AB, which is minus A plus B, over BC, which is minus B plus C, are now in the ratio m is to n. Okay, now I'm going to cross multiply and somehow try and make sure that my equation becomes equal to this. Okay, so now if I cross multiply, this becomes minus Na plus Nb, which is equal to minus m times of B plus m times of C. Okay, now at this point we got to look at this question here very carefully and see how exactly are we going to arrange our answer. So if I look over here, I can see that A and C are on one side and B is on one side. So I will do exactly that. So I will get the B's on one side, so NB plus MB, and then NA plus M times C. Okay, so I'll just write this nicely. So NA plus m times C is equals to, and here I can take B common. Okay, so if I take B common and write it the way that the question wants me to, so we have n plus m inside the bracket, and there you go. That's it, taken care of. Okay, it says in part B, given that lambda times 2 1 plus mu minus 1 times minus 4 7 is equals to lambda plus 1 times 4 and minus 2. Okay, so first thing we're going to do is we're going to we're going to multiply lambda by both the elements. So 2 lambda and then just lambda. Okay, so let's make a matrix here. Plus minus 4 mu plus 4. Okay, so I should explain what I've done over here is that I've multiplied mu by minus 4 and also minus 1 by minus 4. And we're going to do the same thing with 7 also. So mu minus 1 minus 7. And what is this equal to? This is equal to 4 lambda plus 4 minus 2 lambda minus 2. There you go. Okay, now let's write this nicely. So, and at this point, you should be able to see where we're going with this. So we're headed towards, since we have two unknowns, lambda and mu, so we should be headed towards simultaneous equations. And we have two equations. One is here and the other is here. Now, it's our job to make use of these two equations and find out the value of lambda and mu. So the first equation will be 2 lambda minus 4 mu plus 4 is equals to 4 lambda plus 4. Now the 4 and 4 get cancelled out, and got to be very careful. These signs are scary looking. So 2 lambda minus 4 lambda minus 4 mu is equals to 0. Let's write this nicely. So minus 2 lambda minus 4 mu is equals to 0. Let's divide both sides by, or let's take minus 2 common. So that way we'll have lambda plus 2 mu. Lambda plus 2 mu is equals to 0. Oops, sorry about that. Yeah, there you go. Okay, so here's the first equation, and we can use this equation to make lambda the subject. So we'll do that later on. Okay, so for the next equation, we will use lambda plus 7 mu minus 7 is equals to this. So lambda plus 7 mu minus 7 is equals to minus 2 lambda minus 2. Okay, so a lot of rearranging here that needs to be done. So lambda plus 2 lambda is going to be 3 lambda. Okay, so I've skipped a step there. Plus 7 mu is equals to minus 2 plus 7 is equals to 5. So here is the second equation. Okay, now from this equation I can make lambda the subject, so lambda is going to be equal to minus 2 times of mu, and plug it in over here. So now I have 3 times minus 2 lambda, sorry, minus 2 mu plus 7 mu is equals to 5. So minus 6 mu plus 7 mu is equals to 5, which means that mu is equals to 5. And that, I believe, is the correct answer. Okay, now if you want lambda, for lambda it's just minus 2 times 5, which means that lambda is equals to minus 10, and that's it. Okay, now we move to question number 8, which says a 5-digit number is made using the digits 0, 1, 4, 5, 6, 7, and 9. No digit may be used more than once in any 5-digit number. Find how many such 5-digit numbers are even. Okay, so here's one condition, and also greater than 50,000. Okay, so there are two conditions we need to fulfill. One is that they're even, and the other is that the number should be greater than 50,000. Okay, and the digits that we're talking about are 5-digit numbers. So 1, 2, 3, 4, 5. Okay. Now, for the first digit, how many places, I mean, for the first place, how many digits can we have if we have to make sure that it's greater than 50,000? So we got to have 5, we can have 6, we can have 7, and 9. And for the last digit, if you got to make sure that it's even, so we could have 0, 4, and 6. Now, what happens here is that this becomes a conflict situation. And why does this become a conflict situation is because of the number 6. Now, you have number 6 on both sides, okay? So that's not possible. You can't have one number on both sides because the question categorically said that you may only use, no digit may be used more than once. Okay, so how do we fix that? Well, we fix that by just ignoring 6 from either side. Okay, so what I can do is I can remove 6 from the first digit, okay, temporarily, and then we'll see what needs to be done with 6 later on. Okay, so for now I will say that we just have 3 options for the first place. Okay, so that means 3 or 3p1, and we have 3 options for the second, for the last place also. Okay, making sure that it's even. And we started off with how many numbers? 0, 1, 4, 5, 6, 7, and 9. So we started off with a total of 7 numbers. And out of the 7, 2 of them are gone. So that means we're left with 5. And we have room for 3. So that means 5p3. Okay, so let's work this out. 3 times 5p3 times 3 is equals to 540. Okay, now what we're going to do is, now we are going to repeat the same thing, but this time we'll have 6 over here, which means I can have 0 here, I can have 4 here, and I don't think there's any other number that I can have over here. Okay, so we have one option for the first digit and 2 option for the second. And again, we started off with 7 numbers. Now 2 of them are gone, so we're left with 5, and we have room for 3. So 1 into 5 p3 times 2 is equals to 120, which means now we have, I mean, the total number of numbers that are even and also greater than 50,000 happen to be 660. Okay, so that was part A. Now let's do part B. Part B says the number of combinations of n objects taken 4 at a time is equal to 6 times the number of combinations of n objects taken 2 at a time. Okay, so what this is more like a binomial question. Okay, not exactly a permutation combination question, but yeah, you know the concept that we use in binomial, where we have to expand when we don't know what the value of n is. So it says the number of combinations of n objects taken 4 at a time, which means nc4 is equal to 6 times the number of combinations of n objects taken 2 at a time, which means nc2. Okay, at this point what you should know is you should know how to expand nc4. So how do you expand nc4? N into n minus 1 times n minus 2 times n minus 3 divided by 4 factorial, which means 4 times 3 times 2 times 1 is equals to 6 into nc2, which means n into n minus 1 upon 2. Okay, so like I said, you should know how to expand nc4 without using a calculator. And how do you do that? I'll just give you a quick overview. So you have 4 after c, right? So that means in the numerator you're going to have 4 different numbers, okay, or you're going to have 4 digits. So starting from n, and then for the next digit you'll just go 1 place backwards. So you'll have n, and then if you go 1 place backwards you'll have n minus 1, and then if you go 1 place backwards so you'll have n minus 2, and then if you go 1 place backwards you'll have n minus 3 divided by 4 factorial. Okay, now it's a matter of simplifying this, for which we'll first cancel out as much as we can. So n cancels out with n minus 1 cancels out with n minus 1. Okay, I don't think there's anything else we can cancel out. So yeah, we'll just cross multiply now. N minus 2 times n minus 3, which will expand in the next step, is equals to 4 times 3, that's 12, and 12 times 6 is 72. Okay, so n square minus 3n minus 2n plus 6 minus 72 equals to 0. So now we're looking at n square minus 5n. 6 minus 72 is 66. Is it? No, it can't be 66. It has to be. No, wait, it is 66. 6 minus 72 is 66. Okay. So now we're looking for factors of minus 66 that that leave us, or that add up to minus 5. So that means n square minus 11n plus 6n. Minus 11 plus 6 is positive 5. Minus 66 is equals to 0. So we'll take n common here. So n minus 11. And then we'll take 6 common here. So we have n minus 11 again is equals to 0. So n plus 6 times n minus 11 equals to 0, which means n is either equal to minus 6, which we'll see is not possible, or n is equals to 11. And why is it not possible? Because whenever you're doing this, the value of n is always positive. Whenever you're doing binomial, the value of n is positive. When you're later on doing A levels, or in fact A2, that is when you learn how to expand with negative value of n. So for this, the correct answer is going to be 11. So there you go. N is equals to 11. That's our final answer. So yeah, that was question number 8. Okay, so now we're doing question number 9, which is a question from circular measure. And I should mention that this is a fairly tricky question, but yeah, so I'm gonna try and be as elaborate as possible so that it becomes easier for you, hopefully. So it says here the diagram shows a circle, center O, radius 12. So that means the radius of the circle that you're looking at over here is 12, and rectangle ABCD. Okay, the diagonals AC and BD intersect at O. Okay, so we have AC and BD intersecting at O. That's great. The sides AB and AD of the rectangle have length 6 and 4 centimeters respectively. The points M and N lie on the circumference of the circle such that MAC and NDB are straight lines. Okay, so MAC and NDB are straight lines. Okay, that's great. Then it says show that angle AOD, which is this angle right here, is 1.176 radians, correct to 3 decimal places. Now, there are plenty of ways through which you can work out angle AOD. Now, the way that comes to my mind is the following. So this right here is a 90-degree triangle. Okay, so what we can do is we can work out this angle, and angle AOD is an isosceles triangle, which means that the two angles will be equal. And if the two angles are equal, and if I have those two angles, I can sum them up, subtract from 180, or pi in this case, which by the way reminds me that make sure that your calculator is in radian mode if it's not. And when you do that, you'll have angle AOD. Okay, so that means what I want to work out is angle ADO. Now, in order to work out angle ADO, I have the opposite length and the adjacent length. So that means the trigonometric ratio that I can use is tan. So tan of ADO is equals to opposite upon adjacent. So to work out ADO, we'll take the tan inverse of the answer. So 6 divided by 4, tan inverse of the answer. So we're looking at 0.9827, and so on and so forth. Okay, now if you want angle AOD, so for AOD, here's what I'll do. Pi, which is basically 180 in radian, minus 2 times the angle that we've just worked out. So that means 2 times the answer that we've just gotten. So here's what I'm doing, pi minus 2 times the answer. And I should mention and encourage you guys to use the answer key so that your answer isn't rounded off. And when you do that, you get exactly what you're supposed to, which is 1.176 radians, correct to 3 decimal places. So since this is like a show question, we know for sure that our answer is correct. Okay. Then it says find the perimeter of the shaded region. So for which the first thing I'm going to do is I'm just going to clear this mess up, and I would like to take a screenshot of this and paste it next to the question, paste it next to part B. So, we can do we don't have to do a lot of back and forth. Okay. Now, perimeter of the shaded region means let's first identify all the lengths that we require in order to find the perimeter of the shaded region. So starting from AM, then AB, then BC, then CD, then DM, and then finally the arc length. Okay, excuse my horrible shading, please. But yeah. So these are the 1, 2, 3, 4, 5, 6. Wait a minute. 1, 2, 3, 4, 5, 6. Yeah, 6 lengths that we want. Now, a lot of them are going to be the same, like for example, AB and DC. Okay, but we're not worried about that. So first, we'd like to plan our answer and then get there. And I should mention that the space given over here, well, you have plenty of space, but still make sure that you use it efficiently. So I would like to start with AM. Again, no particular reason behind that. It's just something that came to my mind first. So in order to work out AM, we'll have to do OM minus AO. Now, although I do have OM because it's the radius of the circle, AO is still a question mark. Now, how do we get our hands on AO? Well, for that, what we can do is we can find out the diagonal of the rectangle, which means AC squared is equals to 4 squared plus 6 squared. So we're using Pythagoras theorem over here. And AC is going to be equal to 36 plus 16. So that's 52. And then square root of 52. And AO, since O is the center point, is going to be half of root 52. Okay. Now, you must have noticed that I'm keeping my answer in exact form. That's because I don't want to end up rounding off too soon. So now that I have AM, oops, sorry, it's not a vector. Okay, so AM would be 12 minus 1 upon 2 root 52. Okay, so this is what I'm doing in my calculator. And 12 minus half root 52. So I am looking at 8.39. So AM is equal, and since this is not my final answer, so I'll just go 1 unit extra. So I'll just write 8.394. Okay, so, and this is not just AM, this is also, in fact, what ND is going to be. Okay, now, so we're done with this and we're done with this. The next thing that I would want would be AB and DC, which, and both of them are equal to 6 centimeter. Okay, so, you know, no brainer. And then the length from B to C, which is going to be equal to 4 centimeters. Sorry, centimeter. Okay, so we're done with this, we're done with this, we're done with this. Okay, so what we're left with now is basically the arc length. Okay, so how do you find the arc length? Well, the formula for calculating arc length is basically, so I should mention that we're doing MN, the arc. Okay, so the formula for calculating the arc length is S is equals to R theta, where S is the arc length, 12 is the radius, and theta is the angle. Now remember, the question already made us work out angle AOD, which means if I want this angle, I'll have to do 2 pi minus, what was it, 1.176, because the full circle is going to be 360. So 2 pi minus 1.176. So let's see, what do we get? So 2 pi minus 1.176 is 5 point something, times it by 12. So we're looking at 61.286. So now it's time to just sum it up. So I'll do the total here. So total is equals to 2 times of 8.394 plus 2 times of 6, okay, plus 4 plus 61.286. So how many lengths do we have? So we have 1, 2, 3, 4, 5, and 6. Does that mean we are missing one length? 2, 4, 5, and 6. No, we're not. Okay. So now it's just, now I'm just adding them up. So 61.286 is something I already had in my calculator. So plus 4 plus 2 times 6, which is 12, plus 2 into 8.394. Okay, so now we're looking at 94.7, and if we round this off, correct to 3 significant figures, we should get 94.1 centimeter, which is the correct answer. Okay, so there you go. That was question number 9. Oh, no, wait, that was not question number 9, because we still have to find the area of the shaded region. So for the area, I'd like to do the exact same thing. I'd like to take a screenshot of this and paste it over here. Okay. Okay, now, how do you calculate the area of the shaded region? Well, for that, there are plenty of ways through which you could do that. So one thing that I want to point out over here is that, so let's first write down theoretically how we're going to work it out. So first of all, we will need the area of circle, okay, minus the area of this rectangle, okay, minus the area of rectangle. Okay, that's still not going to be enough, because you need to subtract the area of this region. Okay, now what you can do is you can call this, it's not exactly a segment, but yeah, you know, you could call this minus the area of MADN. Okay, whatever that is, MADN. Okay, so this is what we have to do in theory. How exactly are we going to do it? Let's find out. So as far as the area of the circle goes, well, area of the circle is something we can work out very easily. So area of the circle is basically going to be pi times 12 squared. Okay, so we'll just park it over here, 144 pi, minus the area of rectangle. So as far as area of rectangle goes, area of rectangle is going to be 6 times 4, which is equal to 24. So that means minus 24. Okay, now the other thing that I need to minus is basically the area of this region. Okay, so what I'm going to do now is I'm going to shade it green, okay, so that it's easy for me to point it out. Yeah, this region. Now, how exactly can I find out the area of this region? Well, here's what I can do, okay. So I will first calculate the area of this sector that you're looking at, okay. So area of sector, let's see. So area of sector would be area of sector. So area of sector is going to be equal to, so we have the angle, okay. So the angle we worked out to be 1.176, okay, and we also have the radius, okay. So half r squared theta, so that means half times 12 squared times 1.176. Okay, so let's see what we have. 0.5 into 12 squared into 1.176. So we are looking at 84.672. Okay, so we're almost there. It's area of sector, and then from it we need to minus the area of this triangle right here. Now we can work out the area of this triangle very easily. We don't even have to use the sine formula. Why? Because 4 is our base and this right here is going to be our height, okay, because and this length right here is going to be half of 6 because O is the center point. So minus the area of triangle. Okay, so as far as area of triangle goes, area of triangle would be equal to half times 4 times 3. So 4 times 3 is 12. 12 divided by 2 is 6. Okay, so now it's just a matter of putting it all together. So for that I'll switch to a neutral color. So 144 pi, and from it we're going to minus 24, something that we worked out, area of triangle, and from it we're going to minus the area of the this region that I've highlighted in green, okay, and this region will be 84.672 minus 6. Okay, so now it's just putting it all together. So 144 pi minus 24 minus bracket open 84.672 minus 6. Now we close the bracket and we are finally looking at 349.7, which if we round off correct to 3 significant figures is going to be 350 centimeters squared. Now I know my working is not exactly, is quite haphazard, but yeah, I'll just give you guys a run through. Just 350 is the correct answer. Okay, so to give you guys a quick summary of this would be that first we worked out the area of the circle, okay, and then from it we need to subtract the area of this rectangle ABCD and then the area of this whatever you want to call it, okay. We'll just call it MADN, okay. So we worked out the area of the circle, we worked out the area of the rectangle, and then when it came to working out the area of MADN, the region that I've shaded in green, the working for that is over here. So first we worked out the area of the sector, and from it we subtracted the area of the triangle. So now we have this region, and now we can come back to this formula and just work it out, and that's exactly what we did, and we got 350 centimeter square. Okay, so now we are at question number 10, which says the diagram shows the graph of the curve y is equals to 1 over x plus 2, the whole thing squared, plus 3 over x plus 2 for x is greater than 2. The points A and B lie on the curve such that the x coordinates of A and of B are minus 1 and minus 2 respectively. Find the exact y coordinates of A and B. Okay, so that should be fairly simple. If you have the equation of the curve and you want to find out the y coordinate using the x coordinate, all you got to do is plug in the x value. So when x is equals to minus 1, let's see what is y equal to. Y is equals to 1 over minus 1 plus 2, the whole thing squared, plus 3 over minus 1 plus 2. Okay, so this is going to be equal to minus 1 plus 2 is 1, the square of which is 1, plus minus 1 plus 2 is 1 again, so 1 plus 3, that means y is equals to 4. So the y coordinate of A is basically equal to 4. And then let's do the same for B. So for B, the x coordinate that we're going to use is 2. So y is equals to 1 over 2 plus 2, the whole thing squared, plus 3 over 2 plus 2. Okay, so that means now we're looking at 1 over 2 plus 2 is 4, square of which is 16, and then 3 over 4. So let's work this out. 1 divided by 16 plus 3 upon 4. So now we are looking at 13 upon 16. So the y coordinate is equals to 13 upon 16, and it's best to leave it like that because the question asked us to write down the exact value. Although you can write it in decimal, but then you will have to write all 4 decimal places. Okay. All right. Then we come to part B, which is a 6-mark question. It says find the area of the shaded region enclosed by the line AB and the curve, giving your answer in the form P upon Q minus ln R. Okay. Now, as always, I'd like to first take a screenshot of this question and take it, bring it next to the question. Bring it next to the part that we're solving over here. Okay. Now, so we'll have to plan our answer and we'll have to be very strategic about it. So the first thing that we should ideally work out is basically the area of this shape right here. And the question has been very kind in the sense that it has already made us work out the value of A and B. And these are the values that we're going to use. So this right here is a trapezium. Okay, so I'll write it over here. Area of trapezium. Okay. And the area of trapezium is going to be half times sum of parallel lengths. Now, what are the 2 parallel lengths that we have? They are these 2 lengths, okay? And their lengths are basically going to be the coordinates of A and B. So the coordinate of A turned out to be 4, okay? And the coordinate of B turned out to be 13 upon 16. So as far as sum of parallel length goes, we'll do 4 plus 13 upon 16. And then the height. So height would be this length right here. So this length would be 2 minus 1, which is equal to 3. So let's work this out. So 0.5 into 4 plus, okay, should probably do that in a bracket. 4 plus fraction 13 upon 16 times 3. Okay, so now we're looking at 231 upon 32. So this is the area of trapezium. And now what we have to do is we have to minus, so I'm just going to clear this mess up now. Okay, so now we have to minus the area that is below the curve. Now, in order to calculate the area under the curve, which I should highlight, is basically going to be this area. In fact, I'll probably shade that. Okay, so it's going to be this area that's underneath the curve. So for this, we'll have to do integration, and the limits that we're going to use are going to be -1 and 2. Okay, so now I should mention over here that we are finding out the area that I've shaded in red, for which we'll have to integrate the equation of the curve. So I'll just do this in red, which is 1 over x plus 2, the whole thing squared, plus 3 over x plus 2. 3 over x plus 2. Okay, and we're going to integrate all of this. So I should make a square bracket here. We're going to integrate all of this within the limits 2 and -1. Okay. Now for this, since I'll probably run out of space if I do it over here. So I'll just move over to the next page. Okay. Now, before I can integrate this, and this is something we do with pretty much every question, I first have to make sure that this question right here is integration ready. Okay. So what do I mean by that? By that, I mean that I am going to fix this. I'm going to take x plus 2 in the numerator. Okay. So we haven't started integrating it yet. So 2 minus 1, x plus 2, the whole thing to the power -2, plus, okay, what do we have over here? We have 3 over x plus 2. Now, it is best that we do this separately. Okay, and this is what we're integrating with respect to x. Okay. Now, I'm going to write this separately so that it's easy for me to integrate, and I'll continue from here. So we have x plus 2 with to the power -2 within the limits 2 and -1 that we're going to integrate. Plus, we're also going to integrate. Now, I'm taking this 3 outside for reasons that I'll explain in a bit. 1 over x plus 2. So first of all, understand that it's the same thing, whether I write the 3 here or outside. Now, the reason why I've taken it outside is so that the integration of 1 over x plus 2 will lead to ln, because the differential of x plus 2 is 1, and that's already present in the numerator. So that means the integral of this would just be ln x plus 2. Okay, so now we are integrating it. So integrating this means that this would be, okay, so this would be x plus 2 to the power -2 plus 1. So that's just going to be -1. Okay, divide by the new power. So that's +1. And then we could plug in the limits over here also, or we could just integrate the entire function and then plug in the limits, okay? But I will do it step by step. So 2n minus 1 plus 3 times ln x plus 2, okay, bracket close, and then we'll plug in the limits in this also. Okay, so I'll just leave the 3 outside so that it doesn't interfere with the rest of the working. Limits 2 and minus 1. Forgot to write a minus 1 here. Okay, now, so be very careful when you're plugging in the limits, especially when you have a minus sign, okay, because that can just ruin everything. So here's what we're going to do. So first of all, we'll write it in such a way so that it's easier for us to plug in the limit. So that means I am going to write this. I'm going to take x plus 2 in the denominator. So that way we have x1 over, in fact, minus 1 over x plus 2, okay? So yeah, this will make it easier for me to plug in the limits. Now, if I plug in 2, so I get minus 1 over 4. And then if I plug in minus 1, so I get minus 1 again. And minus 1 plus 2 is 1. Okay, so that's that. We'll simplify this in the next step. And then plus 3. Now, if you plug in 2, so that's ln 2 plus 2, that's 4. And if you plug in minus 1, so that's minus 1 plus 2. That means that is ln 1. Okay, which we'll find out later on is equal to 0. Okay, so what does this become? This becomes minus 1 upon 4 plus 1 plus this, as I mentioned, is 0. And this will leave it in ln as ln 4 only. So that means this becomes 3 ln 4. Okay, now let's simplify this. So minus 1 upon 4 plus 1 is basically positive 3 upon 4 plus 3 ln 4. Okay, now remember this region right here, I mean this value right here was basically the area under the curve, okay? Now what we're going to do is we're going to find out, we have the area of the trapezium, and from it we're going to subtract the area that's below the curve so that we have the area of the shaded region. So I'm just going to switch to a neutral color. Yeah, let's go with purple. So area of shaded region is equal to area of trapezium, which is 231 over 32. 231 over 32 minus 3 upon 4 plus 3 ln 4. Okay, so let's work this out. Okay, so 231 divided by 32 minus 3 upon 4. So we are looking at 207 over 32 minus 3 ln 4. Now, the problem here is that this doesn't match the way that the question wanted us to give an answer as. So over here, you can see that you have just ln r, you don't have a value before it. So that means I need to somehow get rid of this 3 here. And using the rules of logs, 3 will become the power of 4. So now we have 207 over 32 minus ln 4 cubed, which is 64. Okay, I'll just do this on the side here and tell you guys what I've done here. So I've turned this as 4 cubed, which is why it becomes 64. So there you go. This finally gives us the area of shaded region. And again, I'll give you guys a quick summary of this. So what I've done over here is we have worked out the area, that is area of the trapezium, okay, for which we used the formula half times sum times parallel lengths. Half times sum of parallel lengths times height. So parallel lengths were just the coordinates of A and B respectively, and height was this. So we got 231 over 32. And then we had to find the area under the curve so that we could subtract the 2 and then finally find the area of shaded region. So in order to find the area under the curve, we integrated the equation of the curve within the limits minus 1 and 2. And that took a while. So first we made it integration ready, then we integrated it, plugged in the limits, and then finally we just put it all together and found the area of the shaded region. Okay, so yeah. Now we are on question number 11, which I believe is the final question of the paper. So yeah. Okay, so it says here the diagram shows the velocity time graph for a particle P traveling in a straight line with velocity v meters per second at a time t seconds. P accelerates at a constant rate for the first 10 seconds of its motion and then travels at a constant velocity 30 meters per second for another 15 seconds. So you can see it's doing that from 10 to 25. P then accelerates at a constant rate for a further 10 seconds, okay, and reaches a velocity of 60 meters per second. P then decelerates at a constant rate and comes to rest when t is equals to 55. Okay, that's great. Then it says find the acceleration when t is equals to 12. Okay, so this may initially seem like a really difficult question, okay, although I hope I'm wrong. But if you look at t is equals to 12, so that is the part of the graph where it's horizontal. So that means when speed is constant, so this right here is basically representing constant velocity, actually I shouldn't say speed. So when velocity is constant, the acceleration is nothing but 0. Why? Because acceleration is rate of change of velocity, and since there is no change, that means it's going to be equal to 0. Then it says find the acceleration when t is equals to 50. So that means we're talking about somewhere over here. So in order to find the acceleration, now notice that acceleration has been constant from 35 to 55. So all I'm going to do is I'm going to use these 2 points with coordinates 35 and 60 and 55 comma 0 and just simply find out the gradient. Okay, so that's what I'm going to do. So what I'm going to do is I'll do 60 minus 0, y2 minus y1 over x2 minus x1, which means 35 minus 55. So let's see, 35 minus 55 is minus 20. 60 upon minus 20 is equal to minus 3 meter per second square. Okay. Then it says find the total distance traveled by the particle p. Okay, so in order to find the total distance, we have, what do we have here? We have a velocity time graph. Now from prior knowledge, we know that it is area under the velocity time graph that gives you the total distance. Now how do we find the area? Well, we can't do it directly, but we can do it in bits and pieces. So we'll have to divide our shape. So we can divide it into 2 trapeziums and 1 triangle. So the trapezium right here has 2 parallel lengths, 25, and this length is going to be 25 minus 10, so that means this is going to be 15. So half times 25 plus 15 times 30. So what is this equal to? 0.5 times 25 plus 15 is what? Is 40 times 30. So this is 600. Okay. Then we're going to find out the area of this trapezium right here. And the parallel lengths here are 30 and 60. And the height here is 10. So that means half times 30 plus 60 times 10. So let's work this out. 30 plus 60 times 10 divided by 2. So this right here is 450. And then finally we have a triangle over here, the base and height of which are basically 20 is the base and the height is 60. So that means half times 20 times 60. So 60 times 20 is 1200. 1200 divided by 2 is 600. Okay. So now it's just a matter of adding all of them up. So we're looking at 600 plus 600 plus 450. So now we have 1650 as our total distance. And the working that I've done over here is something that you should do over here. So yeah, so that you get the 2 marks. And let's check the answer. Yep, 1650 is the correct answer. Okay, now we're on part B, where it says a particle q travels in a straight line such that its velocity at time t seconds after passing a fixed point O is given by so and so. Find the speed of q when t is equals to 5 over 9 pi. Now we have the equation of velocity, and the question is asking us to find the speed. So aren't they one and the same? The answer is yes and no. I mean, in value they're the same, but speed does not have a negative sign. So all we're going to do is we're going to plug in the value of t in this equation. Okay, so 3 into 5 pi upon 9 minus 4. And when it comes to giving the final answer, now let's first work out what the answer is. So 4 cos 3 into, what do we have? 5 pi upon 9, bracket close, minus 4. So we have minus 2, but since the question is asking for speed, so we'll just write speed is equals to 2 meters per second square, and that, meter per second, not meter per second square, and that's it. Then it says find the smallest positive value of t for which the acceleration of q is 0. Okay, so how do you convert your equation of velocity to acceleration? Well, you do that by differentiating it. Why? Because acceleration is rate of change of velocity. So if you differentiate velocity with respect to time, what you get is acceleration. Okay, so 4 cos 3t, if you differentiate that, so that's going to be 4. Differential of cos is minus sign, so minus sign 3t, multiplied by the differential of the angle, so that's 3, and the differential of 4 is 0. So that means now we have minus 12 sine 3t. Yeah, there you go. And we're going to set this equal to 0. Why? Because acceleration we want to be equal to 0. That means we're looking at sine 3t equals to 0. Now, when is the graph of sine equal to 0? So if you look over here, so the graph of sine is equal to 0 at 0. And the next time it's equal to 0 is when it's equal to 180 or pi. So what that means is when you do sine inverse of 0, so that could either be equal to 0, it It could be either equal to pi or it could be equal to 2 pi, because that's when it is 0 again. But the question asked us to find the smallest positive values. So that means we're going to ignore 0 and 2 pi and just stick to pi. And if you make t the subject, so t is equals to pi upon 3. And that is your final answer and also the correct answer. Okay. Now we're on part 3, where it says find an expression for the displacement of q from O at time t. Okay. So we have the equation of velocity, right? And we want to use that. Whoops, sorry about that. We want to use that to find out the equation for displacement. Okay, so let me just copy this equation. No, wait, not this one. This one, yeah. Just copy this and paste it over here. Okay. Now, what do I need to do in order to convert velocity to displacement? The answer to that is you need to integrate velocity. Okay. And that's what I'm going to do. So integral of cos is sine, so 4 sine 3t divided by the differential of the angle minus 4t. Now, since the velocity was measured after passing through O, that means at t is equals to 0, the displacement was also equal to 0. So remember, whenever the object starts from O, so at that point, time is 0 and so is the displacement. And why do we need to know this? Well, because when we integrate, we get a plus c. So we need this piece of information to find out what the value of c is. So now that we know what displacement is, so 4 sine 3t upon 3 minus 4t plus c, I'm going to plug in the coordinate 0, 0 to work out the displacement. So 0 is equals to 4. Now sine 3 times 0 is going to be sine 0, which is equal to 0. So 4 times 0 upon 3 minus 0 plus c. So luckily c is equals to 0. And now we can form our equation that s is equals to 4 sine 3t upon 3 minus 4t is that's what displacement is, and that is the correct answer. So yeah, that brings me to the end of this paper, and I hope every question that I've explained in this video is clear to all of you. And let me know what other papers and concepts you want me to make videos on, and I will do that inshallah very soon. So yeah, that's it. See you guys in the next video. Until then, take care. Bye bye.